Did you know that ancient human remains contain the DNA of various diseases that can help us find their origins and their cure? Let's find out how scientists are trying to unravel this mystery of ancient DNA. Ancient human skeletons preserve the DNA of bacteria and viruses, offering scientists a unique insight into the infectious diseases that plagued our ancestors and the history of human health, opening doors to a deeper understanding of our past. In the 16th century, the area now known as Mexico experienced a sharp decline in population. Many believed that Europeans brought a deadly illness from Europe, decimating the indigenous populace, though the exact pathogen was a mystery for centuries. Recently, a team of dedicated scientists successfully extracted ancient viral DNA from the teeth of these long-gone victims, buried beneath structures in New Mexico, revealing an unexpected truth about the origins of the disease. Their findings challenge previous beliefs. The DNA suggests that the victims suffered from hepatitis B and human B19 parvovirus, viruses that, rather than originating in Europe as once thought, likely came from Africa, reshaping our understanding of historical disease transmission. Scientists in Mexico notes that some of the analyzed victims were genetically African, supporting the theory that these viruses arrived in the Americas due to the transatlantic slave trade, which saw Africans forcibly transported to the New World. The horrendous conditions aboard European ships where enslaved Africans were held were breeding grounds for disease, allowing infections like hepatitis B and parvovirus to spread rapidly among the captives, who would then introduce these pathogens to new lands. Upon reaching the Americas, these diseases found a population that had never been exposed, making the indigenous people extremely vulnerable. These foreign viruses contributed significantly to the massive population decline of indigenous communities. This significant revelation forms part of the expanding field of paleomicrobiology, where researchers obtain microbial DNA fragments from ancient skeletons, allowing them to diagnose diseases or conditions that afflicted individuals hundreds or even thousands of years ago, shifting our perspective of historical health. For instance, smallpox, caused by the variola virus, was a devastating disease that plagued humanity, and while anecdotal accounts suggest its existence since 10,000 BC, the oldest confirmed case was from a 17th-century Lithuanian mummy until groundbreaking research in 2020. A researcher from the University of Cambridge discovered variola virus DNA in Viking skeletons from around AD 600, revealing that the dreaded disease was present in Europe 1,000 years earlier than previously confirmed cases, indicating that traveling Vikings might have spread it. Additionally, another revelation from ancient DNA analysis sheds light on the origins of the plague. A study from 2015 revealed that Y. pestis, the bacteria-causing plague, had been present in humans for over 3,000 years before the first recorded pandemic. This bacterial research unveiled that Y. pestis might have spread through human contact, resulting in a milder version, until mutations allowed it to infect fleas, which then transmitted a more deadly form, leading to the bubonic plague, decimating Europe in the 14th century. Another historical disease, syphilis, believed to have been introduced to Europe post-Columbus's voyage to the Americas in the late 15th century, has its origins contested, with new evidence suggesting it might have been present in Europe earlier. A 2020 research detected strains of the syphilis-causing bacterium, Treponema pallidum, in remains predating Columbus's return, implying that syphilis might have already been circulating in Europe, reshaping our understanding of the disease's origins. Syphilis, like many other diseases, is believed to have spread alongside expanding trade routes. As human societies grew, intermingled, and established trading networks, they inadvertently opened pathways for pathogens, forever altering human health landscapes. This understanding, however, is limited, as microbial DNA can only reveal so much. While it's true that DNA can survive for extended periods, it's unlikely that diseases could become pandemics before the advent of large, settled human communities around 12,000 years ago. As humans transitioned from nomadic to settled lifestyles, Establishing the first cities, they created conditions ripe for disease outbreaks as greater population densities and interactions facilitated the spread of infectious agents in ways previously not possible. A particularly rich source of ancient microbial DNA is dental plaque, a substance that accumulates on teeth over time. Hardened plaque, or tartar, can entrap ancient bacteria and viruses, granting invaluable insights into the health and lifestyles of past civilizations. For example, a multinational medical project is currently utilizing dental plaque to reconstruct how leprosy, a devastating disease, was managed during Europe's Middle Ages, suggesting that rather than isolating patients, societies might have provided them with care. Dental DNA sequencing also holds promise for revealing insights about non-communicable diseases, NCDs, like heart disease, diabetes, and Alzheimer's, by analyzing the oral microbiome, the diverse collection of microorganisms inhabiting the mouth. Anthropologists suggests that by understanding the oral microbiomes of ancient people, we can infer the prevalence of these chronic diseases in ancient times, challenging the notion that they're exclusively modern ailments. Evidence, such as ancient Egyptian writings describing symptoms resembling diabetes, suggests that while these non-communicable diseases might not have been as prevalent in ancient times as they are today, they certainly weren't absent. In conclusion, as technology continues to advance, the scope of understanding past diseases expands. Combining archaeological findings, oral traditions, and ancient microbial DNA analysis creates a comprehensive view of human health through the ages. Thanks for watching. Please do like and subscribe.